Every time you open Facebook or Twitter, a massive distributed system decides what you see within milliseconds. Let's design it step by step.
Have you ever stopped to think about what's actually happening behind the scenes when you scroll through your news feed? We're talking about a system that has to work for millions of people, all at once. Today, we're going to tear one of these systems apart and see exactly how it's built for massive scale, and just as importantly, resilience. Let's jump in. So, picture this. Someone posts something that just explodes online. It goes viral. Suddenly, millions of people are hammering the refresh button. Your database servers just give up. They grind to a halt. The whole system just buckles. And poof, the newsfeed is gone. It's a total collapse. That single point of failure, that's exactly what we're here to design against. And that really gets us to the core question, right? How do you actually build a system for, say, 10 million people using it every single day? A system that doesn't just feel fast, but is genuinely tough. One that can handle a constant flood of new posts, new photos, new videos, without ever breaking a sweat. Okay, so here's our game plan. First, we're going to look at that viral post problem and figure out why simple designs just fall over at scale. Then we'll hit the key insight, splitting the problem into two core flows. From there, we'll get into the secret sauce, the fan-out strategy, and then dive into all the data, caching, and storage that makes it work. After that, we'll talk about building for resilience, and we'll wrap it all up with the core design principles you can take with you. All right, let's start with that system failure. What actually causes it? Well, it all starts with the most obvious, kind of simple approach. You might think, hey, every time a user opens the app, I'll just ask the database to grab the latest posts from all their friends. And you know what? For our handful of users, that totally works. But when you're talking millions, that simple idea becomes your system's single biggest nightmare. So what's the real villain here? It's one single, incredibly heavy database query. Every time you refresh your feed, the system is trying to do this massive, complicated dance, joining tables, figuring out who all your friends are, grabbing their latest posts, and sorting everything. When millions of people do that at once, you create a huge bottleneck. And even with clever tricks like indexing, the database just can't keep up. The result? Your users are just staring at a loading spinner, and that's no good. So to fix this, we have to completely change how we think about the problem. The newsfeed isn't one single thing. The big aha moment is realizing you have to split it into two totally separate operations. There's the moment a user publishes a post and the moment a user views their feed. These are two completely different paths, and they have very, very different needs. And this split is absolutely key. On one side, you have the write path. That's all about getting a new post into the system. It needs to be super efficient at handling new data. On the other side, you have the read path. This is all about delivery, getting the feed to the user's screen in a blink of an eye. By treating these as separate problems, we can optimize each one for what it does best. We optimize the write path for efficiency, and we optimize the read path for pure, unadulterated speed. So how do we get that read path to be lightning fast? The answer is a strategy called fan-out. And here's the magic trick. Instead of building the feed when the user asks for it, we're going to build it before they even ask. We pre-compute it. When someone makes a post, we immediately fan out that post and stick it into the feeds of all their friends. That way, it's just sitting there, ready and waiting. You see, the real genius of the fan-out strategy is all about when we decide to do the hard work. With what's called a push model, or fan-out on write, we do all that heavy lifting the second a post is created. The upside? Reads are ridiculously fast. The alternative is a pull model, where we generate the feed on demand, but that just throws us right back into the slow query problem we were trying to escape. For an amazing user experience, the push model is the only way to go. Okay, let's pop the hood and look at the engine of this whole system, the fan-out on-write architecture. This diagram right here shows the entire journey a post takes, from the moment it's created to the moment it lands in a feed. We're going to walk through this step by step. Think of the write path as a super efficient 5-step assembly line. Step 1, a user's post hits our web servers. Step 2, the post service immediately saves that post data. Step 3, the fan-out service goes and asks our graph database, hey, who are all this person's friends? Step 4, all that info gets bundled up and dropped into a message queue. And finally, step 5, worker services grab that message and do the real work, updating the newsfeed cache for every single friend. Now, that message queue we mentioned, it's kind of the unsung hero of this whole operation. The best way to think about it is like a central post office. The post service can just keep dropping off millions of letters, our posts, and it doesn't have to wait around for them to be delivered. This completely decouples the system. It means we can handle huge traffic spikes, and it guarantees that even if the delivery workers get backed up, no post ever gets lost. So we've got the flow down. Now let's talk about this system's memory. Where does all this stuff actually live? Because honestly, making the right choices here for caching and storage is the difference between a system that absolutely flies and one that just crawls. The real secret to that super fast read path is our cache. We use a high-speed in-memory database like Redis, and it holds the pre-computed feed for every single user. Now, here's a crucial detail. We don't store the entire posts in there. No way. We just store a list of post IDs. And we use something called capped lists to make sure we're only holding on to the most recent IDs. This keeps the cache incredibly small, incredibly fast, and super responsive. When it comes to our main storage, it's all about using the right tool for the right job. For the actual content of the posts, we need a NoSQL database like Cassandra that's built to handle a fire hose of writes. For media, all the images and videos, that goes into an object store like S3, which is cheap and scales forever. And for that complicated web of who follows whom, we use a specialized graph database, which is amazing at quickly navigating those relationships. It's a whole layered approach. Look, a fast system is great. But a system that actually stays online when things go wrong, that's even better. So now we have to talk about resilience. You have to build your system with the assumption that things will fail and design it to handle those failures gracefully instead of just collapsing. One of our best tools for this is a service proxy like Envoy. Honestly, the best way to think of it is as a smart little traffic cop that sits right next to every one of our services. If it notices a service is struggling, maybe it's slow or throwing errors, it flips a switch called a circuit breaker. It just stops sending traffic to the unhealthy service. This is huge because it prevents one small problem from cascading and taking down the entire system. There's an old saying in engineering, you can't fix what you can't see. And that's why observability is totally non-negotiable. We use tools like Prometheus to constantly monitor the health of every service in real time. Then we use Grafana to build dashboards that turn all that data into something we can actually understand at a glance. And with a tool like Jaeger, we can follow one single request on its journey through the entire system to find exactly where things are slowing down. This toolkit is what lets us find and fix problems before users ever even notice them. Wow, okay, we have covered a ton of ground. So let's zoom out for a second. Let's take this whole complex architecture and boil it down to a few core principles, the key takeaways that you can apply to pretty much any big system you're working on. So if you remember anything, remember these 5 rules of thumb. 1. Decouple your services with message queues so you can absorb huge spikes in traffic. 2. Cache absolutely everything you can at every possible layer to make reads super fast. 3. Keep your web servers stateless. This makes adding more capacity as simple as turning on new machines. 4. From day one, design your system to scale horizontally, not vertically. And 5. Monitor everything, always. These 5 principles are really the bedrock of any system that's built to last. So at the end of the day, what did we really build here? It's so much more than just a feature. It's a promise you make to your users. It's a promise that their feed will be fast, it will be available, and it will be up to date every single time they open the app. Building a system like this isn't just about writing code. It's about engineering trust. Thanks for tuning in.
Like, share, and subscribe to my channel for more AI insights. I'm the Code Architect. See you soon.